Dear students, in the last class we have finished 5.7 exercise. Okay, that was second order derivative. We know second order derivative and we have done exercise also. Okay, now let us go for 5.8 concepts and exercise. In this class we will complete exercise also. Why? Because only 6 questions are there. Small concept, Rolle's theorem and mean value theorem. 3 questions I think on Rolle's theorem, 3 questions on mean value theorem is there. See, less questions they have given me, so that may be not much important for examination point of view, I suppose. Okay, let us see what is Rolle's theorem and mean value theorem, and I have written some points. If you compare these points, automatically you are able to understand. See, normally all we are studying about functions only. This is also about function, but without differentiation or something, this will not come. That is why differentiation is related in this function, and limits also is there. Continuity, differentiability, and the derivative, all are there. Okay, see, let us understand first what is Rolle's theorem and mean value theorem. First, let us understand Rolle's theorem. Then we go for mean value theorem. We compare and analyze it. Then easily we can understand. Then we go directly exercise. Okay. See, this is Rolle's theorem. Rolle's theorem or any theorem about function only. See, this is the function f a b belongs to R or tends to R. See, tends to R means these are real numbers. Like in this function, real numbers we are keeping. That means real valued function, real function, like we have to understand. Okay. But this bracket is matters. Okay, here this is not a parenthesis, this is a bracket. That you keep in your mind. Okay, like this only how to write. Bracket only how to write. Don't write parenthesis here. Where parenthesis has to write, there only parenthesis has to write. This is parenthesis, 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 bracket. Okay, both are different. F bracket AB tends to R, first condition. That means this function is a real function, real valued function. Like you can write it. Why? Because R is a real number. Okay. Now see, this function is continuous on. See, all about function only I am telling. Okay. Here also function, function, but derivative of the function. Dash means derivative. Function, function. Okay. This function is continuous on AB, but closed interval. Closed interval. Closed interval means see, this function is continuous on A also, B also, and in between A and B. All. Okay. Function is continuous on closed interval AB. Function is differentiable on open interval AB. That means see, on A this is not differentiable. On B this is not differentiable. Why? Because A greater than A, less than B. That means from A to B. But A and B should not be included when open interval comes. Okay, differentiable. Function is differentiable. Okay, see, continuity, differentiability, we have seen several questions we have done. By seeing the function itself, we can say whether it is a continuous or not. If after continuous only, differentiability will come. If not continuous means automatically not differentiable. That's all. This all we have known. Okay, we need not go back that much. If you want, then you can go back to those videos. F of A should be f of equal to f of B. This is very important. See, this condition is for Rolle's theorem, not for mean value theorem. Until here, these 3 conditions are there for mean value theorem also. Function, closed interval, belongs to real number, real valued function, real function. Continuous, closed interval, that means it is continuous on A and B both also. But differentiable on open interval AB, that means it is not differentiable on A and not differentiable on B, but greater than A and less than B, it is differentiable. Okay. Until here, those 3 conditions are valid for Rolle's theorem and mean value theorem both. Okay. Now you see, f of A is equal to f of B. That means what are AB? These are limits. See, this function is from -3 to +4. That means see, f of -3 is equal to f of 4. Like that you have to understand here. Okay. A will be lower limit and B will be upper limit of the real numbers. A and B are real numbers. Here we have already written. Okay. If this is the condition, f dash c means what? I will tell. F dash x means what? F dash x means derivative of this function. Here we are writing function means derivative also will be there. How? Already we have written here differentiable like. Differentiable means derivatable, derivable. Okay. This function is derivable and the derivative is f dash x. In that f dash x, if you substitute f dash c, then that should come 0. Okay. What is that c? C may be any point between A and B. What are AB? Here only. These are ABs from lower limit to upper limit. -2 to +4 is there. In between -2 to +4, C will be in between any point. Say it may be after -2, -1 may be there, 0 may be there, 1 may be there, 2 may be there, 3 may be there. But -2 and 4 should not be there. Why? Because you see minus A and B are open intervals here. That means C is not equal to A, C is not equal to B. C belongs to A, B open interval. A greater than A, less than B. This is the condition. So that means there is a point where derivative of that function is going to become 0. This is called Rolle's theorem. See, they give one function, they will give these limits also. They will ask us to check this Rolle's theorem. Then we will see whether this is a real value function. Yes, continuous. If this is the function itself, we can say continuous or not. Differentiable, yes, differentiation is going to come differentiable. F of A and f of B, you see both. If both are equal, then you proceed further f dash. All these conditions are still satisfied until now. Finally, derivation equal to 0 also you have made, but finally C that is not in between A and B means that is not satisfied Rolle's theorem. That C also should be between A and B. Okay, this is the Rolle's theorem. Rolle's theorem means we can say a function is having one point C which is between A and B. At that point, derivative of that function will be 0. At that point, derivative f dash c will be 0. Okay, like that also we can say. But theory and all nobody asks. See, 6 questions we are doing. By doing questions itself, we can get more concept. Okay. Come to mean value theorem. See, this function is A to B real valued function and closed interval same. This function is continuous on closed interval A to B same. This function is differentiable open interval A to B. That means from A to B, not A or not B. Why? Because open interval. Same. So Rolle's theorem. Okay. See here, f of A is not equal to f of B. Why? Because see, f dash c something is coming means, here you see, logically if you observe, f of A is equal to f of B means f dash c what is going to become? 0 it is going to become. You see here. Both are equal means automatically numerator is going to become 0. Then this is going to become 0. If it is going to become 0, then we will go for Rolle's theorem. Okay? Not mean value theorem. If not equal to 0, then we will go for mean value theorem like that we can think. Or else they will ask you to see whether it is following mean value theorem or not like. Okay? See. Differentiable. F dash c, derivative of this function at one point. What is that point? That point is in between A and B. See, this is common for both C. See, these 3 and 4th point all are common. F of A is equal to f of B. F dash c is equal to 0 is for Rolle's theorem. F dash c is equal to f of B minus f of A by B minus A. This is for mean value theorem. Okay? That means this here also you can find this point B, C such that this is f of B. What is B and A? These real numbers only. Okay? That means C also real number. This is mean value theorem. What you do, you note down this. Pause and note down. Why? Because you note down like this only. You can compare and easily grasp. Okay? We will go examples. Sorry, not examples. Exercise. 6 questions are there. 6 questions we will do. You are going to understand the concept. That's all. Okay? Let us go for exercise 5. Okay. See the first question in exercise 5.8. Like this, they only will ask. Verify Rolle's theorem for function f of x is equal to x square plus 2x minus 8, where x belongs to minus 4 to 2 closed interval. That means this function is applicable on 4 also, minus 4 also, 2 also. Okay. See how I am proceeding. First condition for Rolle's theorem is f of a comma b closed interval tends to real number. Okay. That means f of a is what? Minus 4 comma 2 tends to real number. Is it satisfied? Yes, satisfied. Satisfied. See, satisfied Rolle's theorem. We are talking about Rolle's theorem only. All we are writing Rolle's theorem, this thing. Why? Because f dash c is equal to 0 means Rolle's theorem. F dash c is equal to f of b minus f of a by b minus a means mean value theorem. That we are not writing. Why? Because we are seeing for Rolle's theorem. First condition satisfied? Yes. Then go for second condition. Second condition is what? Second condition is continuous. Okay, let us write. f of x is equal to x square plus 2x minus 8 is continuous on, see, continuous on closed interval minus 4 2. Satisfied. That is why we have written continuous, or else we will write not continuous. Okay, this is continuous on a and b. A and b means here minus 4 and 2. See how I have written a continuous like. Why? Because we have got several questions experience. By seeing the function itself, we can say whether it is a continuous or not. Why? Because if the same function, if it is like this, you see, x square plus 2x minus 8, where x is less than or equal to 2, x square plus 2x plus 8, where x is greater than 2. If such conditions are there, then we have to see whether continuous or not like. But such logical controls are there here? Not there. This is a simple polynomial function. Continuous only. Several questions we have done. Okay? Several questions. We have got experience. That is why we have written this is a continuous function. That's all. Okay? Or else please watch my continuous and differentiability videos. Okay? Okay. This is a continuous. Second question or second condition also satisfied. Continuous like. Okay? Write a third condition. F of x is equal to x square plus 2x minus 8 is differentiable. Differentiable on minus 4 to but open interval. See here earlier also continuous on minus 4 to, but even minus 4 to, even if you close also, it will be a continuous function for any number. For any number, all numbers it is a continuous function. But for minus 4 to also continuous like we can understand. Here also you see this function is differentiable or derivatable for any numbers. But for these numbers also this is derivatable. How we can say differentiable? First point, all differentiable functions are continuous functions. Continuous means then we can go for differentiable. If here itself not continuous means we can straight away write not differentiable. Okay. After continuous, all functions are differentiable? Not. Why? Because see, modulus function we have seen that is not differentiable. Okay. That is why all functions are not differentiable even though continuous. But this is not modulus function. This is normal function only, differentiable only. Okay. This is normal function. Why? Because what is derivative? 2x plus 2 is the derivative of this function. That is why if derivative is coming means differentiable, that's all. But why? Because we have done derivatives also, differentiables. Okay. That is why we can say that this is a differentiable functions, not only minus 4 to for all. We can say minus 4 to also this is differentiable. See, for continuous closed interval, for differentiable open interval, like that you have to write. This you have to follow very clearly. Okay, in your examination. Okay, this also I have written. Then what is the third condition? F of A should be equal to f of B. Then write f of A and f of B. Find f of A. F of A is equal to, what is A? Minus 4. Minus 4 square plus 2 into minus 4. 2 into minus 4 minus 8 is equal to, see, minus 4 square 16, minus 8 minus 8. Minus 16 plus 16, 0. Is it okay? 16 minus 8 minus 8, 0. Okay? This is for f of a. Write down f of b also. We will do one thing. See, f of a we have written here, but f of minus 4 also we will write. F of a, that is equal to f of minus 4. Okay? Like this we will write. F of b. F of b, that is equal to f of 2. B is 2 here. Okay? That is equal to. Okay. Write down. Then you substitute 2 square plus 2 into 2 minus 8. 2 square is 4. 2 into 2 is plus 4 minus 8. 4 plus 4, 8 minus 8 is 0. Now you tell me whether f of a is f of equal to f of b. F of a is equal to f of b tends to f of minus 4 equal to f of 2. Okay? Why? Because both have become 0. Then see, until here, all conditions are satisfied by Rolle's theorem. Okay? Okay. We will see. If any condition is not satisfied, then we will write that condition is not satisfied. That is why this is not following the Rolle's theorem. Or else, every time you did not write followed the condition, followed the condition. Let us see next condition. After f of b is equal to f of a, what is the condition? F dash c. F dash c means what you have to do? First you have to write f dash x. Okay, write down. See, f dash x is equal to, that means derivative, 2x plus 2. Is it okay? Definitely okay. Why? Because x square plus 2x minus 8 you need not do. 0 will come. 2x plus 2. 2x plus 2 is f dash x. What about f dash c? C you substitute 2c plus 2. Okay? You keep. Then you go for this one again. F dash c is equal to 0. But as per Rolle's theorem, f dash c is equal to 0. Okay? For checking. Then you write down 2c plus 2 is equal to 0. Okay? 2c plus 2 is equal to 0 means 2c is equal to minus 2, c is equal to minus 1. Is it okay? Definitely okay. Again you write c should belongs to a, b, open interval. That means c should belongs to minus 4, 2. Okay? Then minus 1 belongs to minus 4, 2. Is it correct or not? First you tell me. This minus 1 is in between minus 4 and minus 2. Yes, but this is not equal to minus 4, not equal to minus 2. But see, in real number line, minus 4, minus 3, minus 2, minus 1, 0, 1 will come. In between minus 4 and 2. In between minus 1 already is there. That is why this is valid. Now finally you can write, this function is satisfied for Rolle's theorem or following Rolle's theorem. Write down. This function is following or satisfied Rolle's theorem. You understand now how it has come? How we can confirm this? That means this function is following the Rolle's theorem. Why? Because this function is a real function. Real numbers are there. Minus 4, 2. Okay. And this function is continuous. We know this function is differentiable. 2x plus 2. Differential derivative is coming. This function f of a is equal to f of b has come. Both are 0. That means equal. Okay. F of a is equal to f of b has come. This function's derivative is equal to 0. Also we have tested. Then we have found that c point. that C point is between A and B. All conditions are satisfied. That is why we can confirm that this function is satisfied or following the Rolle's theorem. Okay. Okay. Let us go for second question. Okay. Okay. See the second question. In second question, three parts are there. First part, second part, third part. Each part we will do separately. First, I have written only first part. Examine Rolle's theorem. This question also on Rolle's theorem only. F of x is equal to greatest integer x. Greatest integer function x. F of x is equal to bracket x. This bracket x we can say greatest integer. Greatest integer is what and all we know very well. That is not a continuous function. Why? Because left hand limit is not equal to right hand limit. Why? Left hand limit slightly less than 5 if we give, automatically, see, or don't take 5 but 6 you take. Slightly less than 6 if you take, what will come? 5 will come. Slightly greater than 6 if you go, what will come? 6 will come. Then left hand limit is not equal to right hand limit. Why? Because left hand limit is 5, right hand limit is 6. Then this function is not continuous. If see, this function should be continuous between 5 and 9 all points. Some points it is not continuous, means this is not continuous between 5 and 9, we can write. If this is not continuous, automatically not differentiable. Not differentiable means we need not do f dash c. Why? Because not derivatable. F dash means derivation only, na? See, the concepts you have to know. Okay, let us proceed. But how to write? In proper way, you have to write. First condition is satisfied. Why? Because this is a real valued function. Write down. F a comma b closed interval r comma f 5 comma 9 closed interval are satisfied. Okay, this is a real valued function. First of all, this should be a real valued function. Okay, satisfied. This condition satisfied. But next condition is continuous condition. Write down. F of x is equal to greatest integer x is not continuous on 5, 9. Why? Because just now we have discussed it. This is not continuous. Okay. 5 also should be continuous, but 5 also it is not continuous. 9 also, 9 is continuous. Why? Because see, slightly greater than 9 also if you give input, see, you are not giving actually here. Why? Because up to 9 only you have to give. Closed interval means. Okay. But 5 and 9 you leave for the sake. In between 6, 7, 8 if you see, in 6, 7, 8 this function is discontinuous. This function should be continuous at all points. Then only we can call continuous function. But not continuous, then first condition, second condition itself it has failed. And not derivatable also. If it is not continuous means not derivatable. That also you write. I am writing easily. F of x is equal to greatest integer x is not derivatable or derivable. Derivable on 5, derivative you have to write open bracket. Okay, 5 and 9. Okay. See, not derivable means there is no question of f dash c. F dash c doesn't exist. F dash c should come 0. But not exist means not derivable. Okay. Write down. This function is neither continuous nor derivable or derivatable. Derivable, all are same. Therefore, this function does not satisfy Rolle's theorem. Okay, this function neither continuous nor derivatable. Therefore, this function is not following the Rolle's theorem. Like that you can write and close. Okay. Let us go for second part. See, the same function they have given, but only limits they have changed. Same greatest integer function only, but now this intervals or minus 2 to 2. Earlier 5 to 9 was there. Even this also not continuous. Why? Because see, at 0, at 1, at 1, minus 1, these functions are not continuous. Then this function is also not following the Rolle's theorem like we can write. But procedure you have to follow. How to write? First of all, write like this. F minus 2 to 2 real number satisfies. Okay, satisfying the Rolle's theorem. But next you write, what is f of x is equal to greatest integer x is not continuous. Not continuous on minus 2, 2. Okay, left hand limit and right hand limit both are going to become different. At minus 1, minus 2 it is less than, left hand limit is going to become minus 2, right hand limit is going to become minus 1. Both are not equal. That is why these functions, greatest integer function is not continuous like we have already seen. Okay, that is why this is not continuous. When not continuous, there is no question of differentiable. Write down. F of x is equal to greatest integer x is not derivatable. Derivable or derivatable, both you can write. Derivatable on, you see derivatable, you write open intervals. Derivatable. Finally write down. Therefore, this function is not satisfying Rolle's theorem. Therefore, this function is not satisfying Rolle's theorem. Why? Because not a derivatable, not continuous function. Okay. We did not see. When this is not derivatable, third condition is f dash c we have to go. F dash c means this is derivative. Derivative is not there. That is why we cannot go further. Okay. We go for third part of the second question. Okay. Okay. See, second question, third part. Now function has been changed. Not greatest integer function. X square minus 1. Polynomial function. And x belongs to closed interval 1 and 2. That means between 1 and 2, 1 also, 2 also. Why? Because closed interval. Oh. Let us write conditions for Rolle's theorem conditions. What conditions are going to satisfy and okay. First of all, see, let me write like this. F 1, 2 tends to are satisfied. Okay. First condition is satisfied. This is a real valued function or real function. Okay. Continuity next. F of x is equal to x square minus 1 is continuous continuous on 1, 2 closed intervals. Okay. See, while writing continuous to closed interval, while writing differentiable open interval. This function is continuous on x square minus 1 is continuous on 1 and 2. I have written. But is it correct? Definitely correct. Why? Because there is no logical control. X square minus 1 if less than or equal to 1 or 2 or some logical controls are there, then we can see whether it is continuous or not. Or else we did not see. This is a polynomial function. Straight away we can write that this is continuous function. Okay. Let us go for derivatable. Derivatable also. Okay. F of x is equal to x square minus 1 is derivatable on 1, 2 open intervals. While derivatable open interval, while continuous closed interval. Okay. This is third condition. It is derivatable like I have written. Whether it is correct? Definitely correct. Why? Because derivation of this function is 2x. X square 2x. X cube 3x square. That means we can do derivative. Derivative is also coming means this function is derivatable. Already continuous and derivatable. Okay? Okay? By seeing itself we can say this function is derivatable like. Okay. That also over. Next condition is derivative you have to find. F of A, F of B also you have to find. Write down derivative. First of all, let me find F of A. F of A is equal to F of 1 is equal to 1 square minus 1, that is equal to 0. 1 square minus 1, that is equal to 0. Okay, 1 square minus 1. Okay. Next, go for f of b. F of b is equal to f of 2, that is equal to 2 square minus 1, that is equal to 3. Okay. Now you see here it has failed. Why? Because f of a is not equal to f of b. But for Rolle's theorem, f of a should equal to f of b. Then only you can go for f dash c. Okay. First you have to, it should satisfy here. F of a should become f of b. Then you can go for f of f dash c. F dash c means f dash x you have to find. Then f dash c you have to substitute. Then you have to make equal to 0 or something like that. Thing will come. First question we have done. Okay. But here f of a is not equal to b. F of b, that means this function as all, here only you can write. Therefore, this function is not satisfying Rolle's theorem. Okay. See, this is second question. Sixth question is same question, but rather than Rolle's theorem, all mean value theorem we are going to do. There, this third function is going to become satisfying the mean value theorem. This theorem is going to satisfy mean value theorem. Why? Because see, for mean value theorem, f of a need not be equal to f of b. That formula is different. Okay. We will do in sixth question only. But no, first you understand this. This function is satisfied up to this. But here f of a is not equal to f of b. That is why this is not satisfying Rolle's theorem. Okay. Let us go for third question. Okay. See the third question. Observe carefully. This is a conceptual question. If f open closed interval -5 to 5 tends to R, this function, real valued function, they have only given, is differentiable. That means f dash c is there. F dash c is there. Differentiable, like they only claiming. Function, differentiable function, and f dash x does not vanish anywhere. See, f dash x should be there, and the f dash x, if equal to 0, then it satisfies Rolle's theorem. If f dash c is not equal to 0, then it may satisfy mean value theorem. We cannot say it may or may not satisfy mean value theorem. F dash is equal to 0 means, again we can say that this is going to satisfy Rolle's theorem. But does not vanish anywhere means not equal to 0. F dash x is not equal to 0. That means f dash c is not going to become 0. Then it is going to satisfy mean value theorem. If that is the condition, then prove f of -5 is not equal to f of 5. That also we will see. What are -5? A, B. F of A not equal to f of B. Like that we have to understand. See how to write this conceptual question and all. First of all, let us see first. Why? Because see, first of all, you see how I am writing. F -5 tends to 0. You write. Why? Because see, this is satisfying mean value theorem. But don't write now itself mean value theorem. Next step we will write. Okay. This they have only given. And again you write. F is derivatable as given, therefore continuous. See, already they have given derivatable. That is why we can confirm that this function is continuous. Where it is continuous? On -5, 5. -5, 5 continuous only. See, while derivatable on -5, 5. Okay. See, these are limits AB. AB different derivatable at this open interval, continuous at this. Why? Because see, differentiable function like they only given. That is why these two conditions it should must satisfy. They are telling that this is a differentiable means these are already satisfied. Like we can confirm, we can take it granted. Like okay. Next condition is what? Next condition, f of a is equal to f of b. That is for Rolle's theorem. Rolle's theorem we are not going to see here. We are going to see mean value theorem. Why? Because by seeing itself we can came no. F dash x does not vanish means what? F dash x you have to find. You see how I am writing. F dash x is not equal to 0 as given. Does not vanish means f dash x is not equal to 0. Okay. Now you see, then what you have to write? As per mean value theorem, MVT means mean value theorem, f dash c that is equal to f dash x. X may be c at any point. F dash x is equal to f of b minus f of a by b minus a. Okay. First you write this, then you write this. What I am writing, you see. F dash x is equal to f dash b means here b means what? 5. F of 5 minus f of a. A means what? F of minus 5. Okay. Divided by 5 minus of minus 5. 5 minus of minus 5 plus 5. That is equal to, this is not equal to 0. Why? Because see, f dash x is not vanishing means f dash x is not equal to 0. Not equal to 0 means what you can write? As above, f of 5 should not equal to f of minus 5. Why? Because if both are equal, then this is going to become 0. If this is going to become 0, where something is 0, but here it is not equal to 0, we have already confirmed, does not vanish like. Okay. As above, f of 5 is not equal to f of minus 5. Prove f of minus 5 is not equal to f of 5. Both are vice versa. Okay. This is the proof, that's all. Okay. This is a conceptual question. Take this, we will go for fourth question. Okay, see the fourth question. Fourth question, they are asking us to verify the mean value theorem. MVT I have written. Okay, so see I have reduced. They have given A, B, and again A is equal to 1, B is equal to 4 also they have given. But we did not take. Why? Because see, directly if you take this, this is going to become A and this is going to become B. That we know very well. That is why I have changed it slightly. Okay. Verify mean value theorem for f of x is equal to x square minus 4x minus 3 on 1, 4 but closed intervals. Okay. Let us write step by step, one by one, all conditions for mean value theorem. For mean value theorem, first 3 conditions are same. Okay. Write down. F 1, 4 tends to R satisfies. Okay. Satisfies the mean value theorem, like satisfied means. Okay. Okay. Next condition is continuous condition. Okay. F of x is equal to x square minus 4x minus 3 is continuous on 1, 4 but closed interval. Okay. For continuous closed interval. Okay. See, how can we say that this is continuous function? Because it is an ordinary polynomial function and there is no logical controls. If logical controls are there, less than, greater than is there means, then we can see whether this is continuous at that point or not there. But here no no logical controls are there. Straight function, polynomial function, that is why continuous. Oh, this experience we have already got. Okay. Next, differentiable. Write down. F of x is equal to x square minus 4x minus 3 is differentiable. Differentiable on 1, 4 but open intervals. Differentiable at open interval on continuous on closed intervals. Okay. But whether it is correct, definitely correct. Why? Because see, if it is not continuous means not differentiable. It is continuous. But even after continuous also, which function is normally not differentiable? Modulus function. This is not modulus function. This is first case. Second case, it is derivatable or not means, see here, derivatable is 2x plus minus 4. 2x minus 4 is derivative of this function. This is derivatable only. Okay. Derivative also is there. 2x minus 4. 2x minus 4. That is why this is derivatable. Between 1 and 4, not only 1 and 4, for all. Continuous for not only 1 and 4, for all. This is continuous function, this is continuous derivatable function. That we know by virtue of our experience. Several questions we have done. Okay. Next, what we have to do? F of b, f of a we have to find. And for mean, not for mean value, not making equal. Why? Because here those are not going to become equal. But before that, first you write f dash x. No, f of a only you find. F of a is equal to f of 1. That is equal to 1 square minus 4 into 1 minus 3. Minus 4 minus 4. Minus 7. 1 minus 7. That is equal to minus 6. Is it correct? See, 1 square 4 into 1 minus 4 minus 3. Minus 4 minus 3 minus 7 plus 1. Plus 1 minus 7 minus 6. Okay, this is f of a. Go for f of b also. Write down. F of b is equal to f of 4. Okay. 4 square minus 4 into 4 minus 3. Okay. 16 minus 16 minus 3. That is equal to minus 3. Why? Because plus 16 plus minus 16 going to get cancelled. Minus 3 is going to come there. Is it correct? 4 square 4 into 4 16 plus 16 minus 16 minus 3. Okay. F of b, f of a. See, for mean value theorem, f of a is not equal to f of b. Okay. But for mean value theorem, what is the condition? This is like this. You see, first I am writing f dash x. You find first f dash x, derivatable 2x minus 4. Is it okay? X square is 2x, 4x is, see, this derivation is 0. That is why we need not write f of x is equal. Then you write again f dash c 2c minus 4. Is it okay? Okay. Then again you write f dash c according to mean value theorem. F dash c is equal to f of b minus f of a divided by b minus a. F of b is how much? Minus 3. F of a how much? Minus of minus 6 plus 6. Okay. B minus a 4 minus 1. 6 minus 3 3. 4 minus 1 3. That is equal to 1. Okay. You see how to write this? F dash c is equal to this one. 2c minus 4. That means 2c minus 4 is equal to 1. Comma 2c is equal to 5, c is equal to 5 by 2. Okay. But what you have to write finally? C should belongs to open intervals of 1 and 4. That means c should be between 1 and 4. It should not be 1 and it should not be 4. But 5 by 2 means 2.5. 2.5 is between this one only. Then you write down 5 by 2 belongs to 1 and 4. 2.5 comes between 1 and 4 only. That is why this function we can say satisfied mean value theorem. Write down. This function satisfying mean value theorem. You write mean value theorem, don't write MVT. Okay. This function satisfying mean value theorem. Why? Because all conditions are satisfied, you see, for mean value theorem. Okay. Like this you have to proceed. Let us go for fifth question. Okay. See the fifth question. This also mean value theorem only. They are asking us to verify. Verified and found satisfied or following the mean value theorem. This function, like we can write if it is satisfied. Okay. What is that function? X cube minus 5x square minus 3x. And what are the limits or controls? A and B. 1. A is 1, B is 3. Okay. Okay. Let us write first what we are going to write. We are going to write like this, you see. F 1, 3 closed interval tends to R satisfied. Okay. This is the real valued function like. Okay. Real valued function only. Okay. That means any real numbers you can give. Like that also you can think. Okay. Next condition is continuity. Write down. f of x is equal to x cube minus 5x square minus 3x is continuous on 1 comma 3 but closed intervals. See, for continuity, closed interval. Okay. For differentiability, open interval. Continuous, closed intervals we have written 1 and 3. Really, is it continuous? Definitely continuous. Why? Because see, this is an ordinary polynomial function and there is no logical controls. Greater than, less than or something like it is there, then we can see whether it is continuous or not. Or else this is continuous not only at 1, 3, this is a continuous function for all numbers, all real numbers. Okay? This all we have done earlier class questions. Next, go for differentiable. F of x is equal to x cube minus 5x square minus 3x is differentiable on 1 comma 3 but now open interval. Continuous, closed interval, differentiable, open interval. We have written differentiable like whether really it is differentiable, definitely differentiable. First point, this is continuous. That is why continuous and not differentiable means until we know that modulus function. This is not modulus function, but ordinary polynomial function. Okay. See, x cube minus 5 square minus 3x, what is derivative? 3x square minus 10x minus 3. Derivative is there. Derivative is there means this is differentiable, that's all. Okay. Not only here, for any value, this can be derivatable. Okay. That is why we have written. Okay. Then go for next. Mean value theorem means f of a, f of b you have to find and f dash x also you have to find, but f of b, f of a should not be equal to each other. Okay. First of all, find f of a. F of a is equal to f of 1. That is equal to 1 cube minus 5 into 1 square minus 3 into 1. Okay. 1 minus 5 minus 3. Minus 8 plus 1. Minus 7. Shall I write? Is it correct? 1 cube, 1. 1 square, 1 into 5, minus 5. 1 into 3, minus 3. Okay. Minus 8 plus 1, minus 7. Okay. That also go over. Now go for f of b. F of 3. 3 cube minus 5 into 3 square minus 3 into 3. Is it okay? 3 cube 27. 3 square 9 into 5 45 minus 45. Minus 3 into 3 9 minus 9. Okay, minus 54 plus 27 minus 27. Is it okay? Definitely okay. Okay. Then go for f dash x. Why? Because now you go for a derivative. F dash x. F dash x is equal to, see, x cube means 3x square minus x square means 2x. 2x into 5, 10x. But here 3x is there. That means 3. This is derivative. But here is the quadratic equation. You have to satisfy solve. F dash c. Because you want f dash c. F dash c is equal to 3c square minus 10c minus 3. Okay. This is in quadratic form it has come. Let it be. We can solve. But you see, what you have to write? You have to write like this. You see, f dash c is equal to, for mean value theorem, f of b minus f of a by b minus a. Okay. F of b how much? Minus 27 minus f of a minus 7. That means shall I write plus 7? Okay. The b minus a means 3 minus 1. Okay. See, denominator is 2, but numerator is minus 20. That is equal to minus 10. See, f dash c both are, you have to make equal. Then you make equal like this. You see how I am writing. 3c square minus 10c minus 3 is equal to minus 10. Is it okay? F dash c is equal to minus 10. F dash c is equal to this quadratic equation. Okay. Then you send one side. 3c square minus 10c. If it comes here plus 10 minus 3 plus 7 is equal to 0. Now you find the roots. 3c square. See, a into c, 3 into 7, 21 plus 21. 3 into 7, 21. Then what are the factors? See, 7 into 3, 21. But minus 10 means minus 7, minus 3. If you write minus 7 into minus 3, plus 21. But minus 7 plus minus 3, minus 10. Okay, same. Okay, write down. 3c square minus 3c minus 7c plus 7 is equal to 0. Okay, 3c you take common. 3c if you take common, c minus 1. Shall I write? Why? Because 3c square minus 3c. Okay, again c minus 1 you have to take common here. C minus 1, if it is there, say minus 7c has to come, means minus 7 you have to keep outside. Minus 7c plus 7. That is equal to 0. Okay, that also okay. Now you see, 3c minus 7 is equal to 0 or c minus 1 is equal to 0. C is equal to 1 or 3c is equal to 7, comma c is equal to 7 by 3. That means c value may be 1 or c value may be 7 by 3. Any one you can take. But what is the condition? C condition is like that. C should belongs to A, B. Open interval. That means C should belongs to 1, comma 3. That means C should not be equal to 1. C should be greater than 1 and less than 3. Therefore, 7 by 3 belongs to 1, comma 3. What is the value of 7 by 3? 2 point something. 2 point something. 2 point something is less than 3. That is why 7 by 3 satisfies this condition. That means all conditions are satisfied. Therefore, C is 7 by 3. C is not equal to 1. Okay, C is equal to 7 by 3. This is correct. Therefore, this function is satisfying mean value theorem. Like that you can write down. Finally, you write down f of x satisfies MVT, mean value theorem. Okay, 7 by 3, not 1. You have to take 7 by 3. Okay, take this. We will go for 6th question. That will be last. Okay, see the 6th question. See, 6th question is nothing but 2nd question only. 2nd question we have seen for Rolle's theorem, 3 functions. And here we have to see for mean value theorem. Examine the mean value theorem for these functions, 3 functions. First 2 functions I have written. You first understand these 2 functions are greatest integer functions at different intervals. This interval is 5, 9, this interval is minus 2, 2. Both are different. But even though whatever may be the interval, greatest integer function is not continuous. If it is not continuous means not differentiable. Not continuous, not differentiable means then you cannot go further. Both are not satisfying mean value theorem also. Why? Because see, it may be for Rolle's theorem or mean value theorem. First 3 conditions should be satisfied. First condition should be a real or real valued function. Okay, these are real valued functions only. But second condition should be continuous. Third condition should be derivatable. But second and third conditions are failed for these both. Okay, that is why. See, I am not writing whatever I have written for Rolle's theorem. Those you copy and for these 2 functions. And finally you write down as above. This function is neither continuous nor differentiable. That is why these functions are not following the mean value theorem. Like that you write and close. That means first part, second part is over. We will go for third part. Third part was not satisfied for Rolle's theorem, but that third part is going to satisfy mean value theorem. Let us see how it is. Examine the mean value theorem for third part. F of x is equal to x square minus 1, where x is having interval 1 and 2. Closed interval. Okay. See, this part, this question, this third part was not satisfied according to Rolle's theorem. But for mean value theorem, once again we will see. Okay. See how we have to write. First condition is like this. You write f 1, comma 2 closed interval tends to R. Satisfied? Why? Because this is real valued function only. Okay. Next you go for second condition is continuous condition. F of x is equal to x square minus 1 is continuous on closed interval. Continuous means closed interval, 1 and 2, closed interval. It is continuous like we have written x square minus 1, but it is correct. Yes, definitely correct. Why? Because this is an ordinary polynomial function and there are no logical controls. X is greater than equal to 1 or 2 or something is there means two conditions, then we can see. Now, no conditions, no logical controls are there. That is why this is a continuous function. We can write left hand limit, right hand limit, both are going to become equal. Okay? Okay. After continuity, differentiability, write down. F of x is equal to x square minus 1 is differentiable on, you see how I am writing, this is open intervals, not closed. Okay? For continuous, closed interval, for differentiable, open interval. This function is differentiable like we have written. Is it correct? Definitely correct. Why? Because this is an ordinary polynomial function and we can do not only at 1, 2, any time this is differentiable. Why? Because see, what is derivative? 2x. 2x is derivative. 1 and 2, if you submit also left hand derivative, right hand derivative are all going to come equal only. Okay? That is why this is derivatable. Okay? We need not see again that complex. These two questions itself is going to become big, this thing. But by virtue of your experience, you have to write this. Okay? Okay? Differentiable also. See, three conditions are satisfied. Then what we have to do for mean value theorem? F of A, F of B, how to find, but you need not make it equal. Find out first. F of A is equal to F of 1, that is equal to 1 square minus 1, that is equal to 0. Okay? Then another condition is F of B, that is equal to F of 2, that is equal to 2 square minus 1, that is equal to 3. But see, for Rolle's theorem, F of A should be equal to F of B. That is why 0 is not equal to 3 like we have written, and we have closed that this is not satisfied for Rolle's theorem. But for mean value theorem, this should not be equal to 0. Then you have to proceed further. Okay, write down. Now derivative you have to find. F dash x is equal to, see what I am writing, f dash x. F dash x is equal to 2x. 2x. X square minus mean 2x. Why? Because 1 doesn't have 0. 2x minus 0, you need not write 2x. Then f dash c, 2c. Okay? But for this another formula is there. Write down that formula. What is that formula? F dash c. F dash c is equal to f of b minus f of a by b minus a. What is f of b? F of b is 3 minus what is f of a? F of a is 0 divided by what is b? B is 2 minus what is a? A is 1. 3 minus 0, 3. 2 minus 1 is 1, that is equal to 3. Okay? But this should be equal to f dash c, 2c. That means you can write 2c is equal to 3. F dash c 2c has come, f dash c 3 has come. That is why 2c is equal to 3. That means c is equal to 3 by 2. Okay. Now you proceed further. C is equal to 3 by 2 means again you know C should belongs to A, B, open interval. That means C should not be equal to A, should not be equal to B. But it is should greater than A and less than B. C. C should equal to 1, 2. Okay. Now you tell me this 3 by 2 is in between 1 and 2. Definitely. Why? Because 3 by 2 means 1.5. Then write down. 3 by 2 belongs to 1, 2. Therefore, this function satisfies mean value theorem. Why? Because all conditions are satisfied, you see. Okay? Finally, see 3 by 2. This 3 by 2 is in between 1 and 2, 1.5. That is why this function is satisfied the mean value theorem. But this function is not satisfied, was not satisfied Rolle's theorem. Why? Because f of a should be equal to f of b, then only Rolle's theorem. For mean value theorem, f of a should not equal to f of b, and this condition it has to satisfy. After this also, if c is not satisfying this condition, c is equal to 1 or equal to 2 means again this is not going to satisfy mean value theorem. Like this concept you have to build up. See, we have finished this exercise. We will stop this class. We will meet in the next class for miscellaneous exercise. That number I am going to give 5.9. Okay. Thank you very much.